All right. Hello, thank you so much for watching our Group 2 presentation. Today we're going to be going through the Kelley Blue Book website. All right, so for anyone that doesn't know what Kelley Blue Book is the leader in the automotive industry, offering their expertise in marketing and selling vehicles. What they are is they're dedicated to improving the automotive industry by acting as a transparent guiding force to improve relations between the buyers and the sellers of cars. And they pair their research and data to the goals of the consumer in order to bridge the gap between consumers, manufacturers, dealers, and lenders at every stage. So Kelley Blue Book reports the market values prices for both the new and used automobiles of all types, including cars, trucks, and motorcycles. And Kelley Blue Book is a trusted resource for consumers understanding the market range and fair purchase price of both new and used automobiles based on what similar consumers are paying and the market conditions. And finally, it acts as a resource and an expert on cars by giving reviews of automobiles and their ratings. It collates user reviews and gives a really helpful breakdown of the 5-year cost to own for many cars. KelleyBlueBook.com has over 10 million unique visitors per month, and the users range from anywhere from industry experts to car salesmen to just the average person looking to get better transparency in the car buying process. So the history of Kelley Blue Book is actually quite a bit longer than you might think. The first guide was published in 1926. And then in 1982, Kelley Blue Book went digital, offering vehicle values and software for dealers, financial institutions, and insurance companies. And then in 1995, KelleyBlueBook.com launched, and within 2 years, it was the most visited automotive site on the internet. In 2000, the new car Blue Book value shows what the consumers are actually paying for their new cars, and it exceeds over 10 million users per month. And finally, in 2010, Autotrader.com acquired Kelley Blue Book, combining two of the strongest brands in the auto industry, and it allowed users to not only see the value of the cars, but also meet with sellers and buyers who wanted their cars. So the technical overview to use Kelley Blue Book is you need to have Windows or Mac or Linux, or you can use the app on your iPhone, iPad, Windows, or Android. So pretty basic. And what the users need to be able to do is search for either new, certified pre-owned, or used cars, and they can see their own car's value. The database automatically narrows through the user's selections. So when you type in that you want a used 1947 car, then it won't show you any cars that were made after that time. It'll only show you the cars that were made during that time. And then users can see and input only the relevant information. If no yellow cars were made for the Jaguar XKR line, then it won't give you the option for yellow.
So here we have the conceptual model that we developed as a group. And so each of us went ahead and went on the website and the app for Kelley Blue Book and kind of looked at how the layout was. Something to keep in mind is that Kelley Blue Book, the database holds hundreds of thousands of cars and vehicles on there. And so to list every single feature or every single attribute for a certain entity just wasn't realistic for this project. And so we've broken it down into 4 entities of zip code, car, style, and feature, and then their associated attributes that you can see there and the relationships between each of those tables. Looking at a certain part within the conceptual model of one-to-many relationships, and so this is between the zip code and the car tables. The reason why this exists is because a car can only have one zip code in which it is currently located. So a car can't be in 2 places at the same time, and so it's only given one zip code value for it. However, looking at the zip code itself, there can be many cars within that same zip code. So there can be 10,000 cars within 84128, and so that needs to be described within the model, which we have here. Looking at the participation relationships, which there's quite a few within our model, a car must have a zip code in which it is located. So again, a car has to be somewhere, right? And so a zip code would be associated with that. Also, a car must have a style associated with it. So that's kind of the trim package. I mean, obviously a car has to have an engine and a drivetrain, and so that's shown here. Features must have a style associated with them. So you have to know the car and the style of it in order to know what features are associated within that, and that kind of limits down the scope of this model, so that you're not looking at, you know, a ton of features that aren't actually available on that specific car and style. Here's the relational model. So this is showing the connection between the 4 tables, and you can see the primary keys there that are underlined, and then the foreign keys there are at the bottom. And so style ID and zip code at the bottom of the car table shows how that relates to those 2 tables. And then style with feature, you can see that feature ID is included within the style table to go ahead and connect those as well. And so again, the table entities that we're going to go in depth with are zip code, car, style, and features. So within the zip code table, it can be a standalone table without the input of a car, since again, a zip code still exists, whether or not a car is actually located there. But it is required for the remaining tables to populate. So when you actually go on the website or the app, it does require you to enter in your zip code before you can continue going through essentially these tables to input your information to figure out, you know, how much is this car. And so this table contains the zip code, which is a unique identifier, the city, the state, and then the code. And so the code is essentially the value of what the car would be, let's say within Seattle versus Salt Lake City, Utah. It's probably going to be valued higher in Seattle, just cost of living and location, compared to Salt Lake City. And so that's identified here. This is some example data that we inputted into the zip code table. So again, there's examples there on the left of actual digit zip codes, the cities that are associated with them in the state, and then the score there on the right, like I was saying. So that's kind of telling you, again, if we're in Seattle, it's going to be valued higher than if the exact same car was in West Valley City. Looking at the car table, so this is the center of the entire database, right? So Kelley Blue Book exists because of cars, and it's required in order for the style and features tables to populate. So you need to know what make and model and those associated attributes within the car table are before you can continue into what styles would be available, and then continue into what features would be available. And so the car table contains the car ID, which is again is the unique identifier for that, make, model, year, mileage, status, condition, and then the style ID and the zip code as the foreign keys to link to the other tables. So here's the example data for you to see. So make, you know, is it Ford, is it Chevy? Model is, you know, what's the specific model within that make? The year, the mileage that it's at, status of, you know, is it new, is it used? Condition, so again, is it excellent, good, fair, poor? The zip code that it's in, and then the style ID so that it can link to the style table. So looking at the style table, it's again populated based on the input values for the car table and its respective attributes to produce this one. Style attributes are limited to the possibilities based on car table that are inputted by the users. We've kind of been discussing going through this. And so this table contains the style ID, which is a unique identifier, style name, car trim, engine, transmission, drivetrain, and then the feature ID is a foreign key to link to the feature table. And there's the example data for that one. Style name, so that's what we code as SUV, sedan, truck, car. Car trim is essentially the package that comes with the car. So again, that'll be located at the usually the bottom right of the back part of the car. You'll usually see that. And then the engine and the transmission associated with it. Drivetrain is, you know, is it all-wheel drive, rear-wheel drive, front-wheel drive. And then the feature ID, which again is the foreign key to link to the feature table. So this is populated based on user input, again for the car and style tables. As I kind of stated earlier, there's thousands of feature options for, you know, interior and exterior of the car. And so for the purposes of this project, this table within this database that we created contains the feature ID, which is the primary key, and the unique identifier, and then the interior and exterior. So you can see that kind of highlighted here with this example data. So the interior, we just did the type of material that the seats are made out of. And then exterior, we just went ahead and did color. And so again, to keep in mind, there's going to be many other options for interior, many other options for exterior. It just was unrealistic for this project for us to go into that. So looking at future ideas, kind of some limitations that would be interesting to expand on is calculation. So we know the data that the user selects, but how do we manipulate a calculation algorithm to give the best price? So we don't know how that necessarily works. We understand how to collect the information from the user, store it in a database, and then we would assume that you assign values based on the information that they input, but then as far as the calculation part, we're not completely sure, and we assume that's with a different program that gets entered into, not necessarily with the database itself. The zip score, again, the location of the car can be dramatically influenced by the car's value, but we don't know how that's calculated. Autotrader.com. So Kelley Blue Book is actually integrated with Autotrader, and it allows users to not only see the price of the car they want, but then to connect with local sellers, matching the requirements. And so we focus solely on just Kelley Blue Book, again, for the project scope, and not necessarily on Autotrader, but it would be an interesting addition in the future. And so we appreciate you, looking at our presentation, and then we're going to go ahead and go into a tutorial just to kind of give you a visual representation of the query codes and descriptions that we're going to be doing listed here. So list the city, state, and zip for a car searched in zip code 90001. List all cities and their scores from a specific zip code with score less than 5. So again, that's the zip code value. Show all features for Ford Explorer. Show all makes that have automatic transmissions older than 2015, have less than 110,000 miles. And so that's getting a bit more specific to see how the various tables interact with each other. List the number of cars in excellent condition for each make. List all cars that are not trucks. List cars searched in the zip codes with the highest and lowest scores. So again, that's the values associated with the zip codes. Calculate the percentage rate for each zip code that would be used in calculating a car's quoted price, and then list percentages with a car's status and condition. And then display cars with above average mileage for 2017. So we'll go ahead with a tutorial right after this, and again, we appreciate you viewing our presentation.
Okay, we're going to demonstrate some of the queries that we've built in our database. So first, let's look at the 4 tables that we've made. This is the car table. You can see we have 10 different cars added with make, model, year, mileage, status, condition, and then an associated zip code as well, and an associated style ID. We have a style table with different styles uniquely identified with an ID, and name, trim, engine, transmission, and drivetrain, and that's associated to a feature table. We have a zip code table with unique zip codes in their city, state, and a score, which is sort of based on the car price in that area. So multiplying a standard car price by a score would give you a geographically relevant car price. And here is a feature table with interior and exterior features, pretty basic because there are so many features that we weren't able to make a comprehensive table, but this sort of serves as a basic. So one of the things that we need to do for this database is to query a city, state, and zip code for a car searched in a particular zip code. So this query uses the zip code 90001, and we're going to find all of the cars in that zip code. So in our database we have 2 cars in that zip code, and you could do that with any other zip code as well. So another query would be to list all of the cities and their price scores from a specific zip code with a score less than 5. So here we're trying to find cities that have a lower price score than others, sort of the lower half. So Rollins and West Valley City have scores of 2 and 4 respectively, and those are the cheapest cities to buy a car. The next query is showing all the features for a Ford Explorer. So Ford Explorer is a make and a model, and we want to get back all of the features associated with that make and model. And here we have the Ford Explorer and SUV with a leather interior and an orange exterior. The next query is to show all of the makes that have automatic transmissions older than 2015 and have less than 110,000 miles. So this one's really specific. What we're trying to capture here is that the application needs to be able to make a query based on multiple conditional statements or multiple criteria. So being able to search for a car with an automatic transmission, a car that's older than 2015 and with less than 110,000 miles all at once, getting multiple specific criteria in a single query. And that returns 3 makes and models: the Ford Escape, the Toyota FJ Cruiser, and the Ford F-150. The next query is to list the number of cars in excellent condition for each make. So let's say we want to know how many Toyotas in our database have an excellent or are in excellent condition. So this shows that there's 1 Subaru in excellent condition and 1 Dodge in excellent condition. And we could run that same query on poor condition or fair condition as well. Next query is listing all of the cars that are not trucks. So what we're trying to capture here is that you could list all of the cars by type. So we could list all of the cars that are sedans or list all of the cars that are SUVs. In this example, we're using listing all cars that are not trucks, and 8 out of the 10 are not. So in this query, what we're trying to do is get a list of the cars in zip codes with the lowest and highest score. So if we wanted to search for the lowest priced zip code, we want to get a list of cars back from that one, or do the same thing with the highest. So we run this query and get back these 4 results. So this is the lowest zip code with a Ford Escape and a Subaru Forester, and then the highest zip codes are tied. In this next query, we convert the zip code price score into a percentage rate that you could multiply by the price of the car, and then also retrieve a car's status and condition as well. So this returns the entire car table with the zip code results joined, and then that score field is converted into a price percentage increase. And you can look at status and condition of the car as well. And in the last query, we are displaying cars with an above average mileage for 2017. So we're calculating the average mileage of all of the cars and then getting a list back of all of the cars that are above that average. And yep, there's our result. And that is a basic demonstration of our database.